Welcome to another stair building education series. Let's go ahead and jump right into it with our first video. Here is a video that was inspired by the current lumber prices. It is May 4th, 2021, and they are just out of control. So I figured I would do my part and try and provide my viewers with a stairway that might be relatively inexpensive to build. However, I do need to point out that I have never built this stairway before and don't really know how strong it's going to be. However, I can tell you that we are going to use 1x6 for the entire stairway, and we are going to start with this frame at the bottom, and I will provide you with the measurements for each one of these items as we go along. And at the same time, I will try to point out wherever I can the areas where you will be attaching them with screws or nails. And you can use 8D nails, 7D nails, or you can use screws that are 1 3/4 to 2.5 inches long. And in this area here, I would recommend between 2 and 3 screws or nails to attach this board to this one, same on the other side. And in case you didn't get it, this board is the same size as this one. Next up, let's go ahead and install our treads or the boards for our steps, and they will be 36 inches long or the same size as this one here. Now you can change the width of your stairway by simply changing the length of these boards. That would be your risers and your treads. I just wouldn't recommend going too much wider than this. However, you could always make it a little shorter. And this stairway might actually be portable to where you could carry it if you did make it a little shorter. All of the steps will have a 1-inch nosing also. If you were to change this measurement, then you might need to readjust the lengths of these boards. And I should point out that the 1x6 we're using are going to be 3/4 of an inch thick, or have a 3/4 inch thickness and a 5.5 inch width or depth. And you don't need to follow my instructions. If you can figure out an easier way, then feel free to do it. So next up on the list will be to build our back wall, and this can be done by laying both of these boards on the bottom and then lining these boards up with the edge of this board here. And if you can, try to make sure that the measurement from here to here and from here to here is the same size. That's how you will know that this is going to be square. If not, you can always use a framing square or some other type of square to square this frame up. And I would recommend doing the same thing to here. And that can be done before you put these treads on. You can just simply measure from this corner to this corner and from this corner to this corner to make sure that everything is square, and then put your treads on. And even if you're off a little bit, it's probably not going to be that big of a deal. And of course, to attach these boards to the other boards, you will need to use smaller nails or screws. And I would recommend between 3 and 5 nails or screws per section here, and space them out in the best way you can. That doesn't mean to put 5 of them all right here. One here, one here, one here, one here, one here, something like that. And then after you have the frame built, you can stand it up like this and then attach this with screws, and try to make sure that if this is square right here, that this right here is going to be plumb or vertically level. But again, if it's off just a little bit, it shouldn't create a problem, because there's a good chance you'll be able to make minor adjustments throughout the building of the stairway. Next up, we will add the next riser and side boards, and you can always use spacers if you want to. I think it would be helpful to simply cut a few spacers the same thickness as the treads, and you could even space a couple of them out here or rip one the full length if you think that will be necessary. So not too difficult. We're simply going up. And of course, here I have some screws sticking up, and I wanted to show you that, along with a couple of nails or screws here, to provide you with an idea of how this stuff can be assembled. And I think the best advice I could give you would be to install screws and nails wherever you have boards that are going to be connecting together. For example, you could attach this tread to this riser by having screws or nails going down, and then maybe spacing them anywhere from 4 to 10 inches apart along the top here and on the bottom. And that's why I got these coming up here. And of course, I will let you choose the length of the screws that you feel will be necessary. And of course, another view of it there, the screws. And I don't think nails are going to work as good here as the screws will, because they will hold a little better while there's pressure being placed on this backboard here. And if at any time after you have built this, you notice that one of these boards starts to move, then it wouldn't be a bad idea to place some type of structural blocks or something underneath the treads that would go in between the bottom of the tread and the top of the floor that the stairs are going to be sitting on. In other words, don't continue to use any stairs, including these, if they are unsafe. And I'm sure that makes sense to most of us. Next up, let's go ahead and add our final riser and side pieces. And the only thing we're going to do different here that we haven't done before will be to add this piece of 1x6 that should be located in the center of the riser. And of course, this board can be attached from both sides, and you could always use construction adhesive or sealant, some type of bonding agent, anywhere you feel is necessary for this project to make it a little stronger. So after this has been installed, you can install the treads, and then by now you should have something that looks like a stairway. However, we're not done yet, and we will need to add a structural brace. This will help prevent it from moving, and in some cases you might not even need this brace. Now, I have a fancy cut up here and down at the bottom, but you don't need that. If you can just cut it to where you can get some nails and screws in on these points, then you should be fine. So again, if these cuts are a little too difficult, don't worry about it. And then I would recommend installing some type of blocks like this. This is going to prevent these boards from moving here while you're walking up and down the stairway, or at the very least, reduce the movement. Now, I have some screws going in from the bottom, and I would recommend driving a few screws in from the bottom and then going on top and then driving the rest of the screws down from the treads into the scrap piece of lumber. And again, you can get carried away and put as many screws in there as you feel like it, or just put a few screws, and then if everything works, then you're good to go. If not, and you get some movement in the treads, then go ahead and install some more screws. Now, even though I made this video so that you could use 1x6 throughout the entire stairway, if you don't want to put these blocks in here, get some 1x12, and then you shouldn't have to worry about it. Or use the 1x6, and you can always add a couple of more of these blocks. For example, you could have one in the center like we have here, or two of them to where you have them spaced more in a 1/3 type of measurement. So for example, if this is 3 feet, you could always have one here about 12 inches and another one here about 12 inches, and then not one in the center. Or you could have one in the center and then just put a couple of more next to it. I mean, if you think about it, people are going to be walking down the center of the stairway. So this is usually going to be the ideal spot for some type of support, blocks, bracing, whatever you're going to use to stabilize the stairway steps. And the last thing I want to point out in the video is that this board right here will need to be a little bit smaller. And the reason for that would be to keep all of the treads the same size. So you could always measure the treads and then measure the riser height to make sure that they are exactly the same all the way up. So if we left this a little longer, then the last step would just be a little bit longer. And obviously that won't be the end of the world, but this is what your stairway should look like. And if you do end up building one of these, I would love to make sure that all of my measurements are correct, and then leave a comment suggesting that they are in the video description area. And of course, this would include any methods that you come up with to make this stronger or faster and easier to assemble. So with that said, let's go ahead and wrap this video up. In this video, I will provide you with a couple of different ways you can attach a stairway to a deck where you do not have a structural support. And you could always design the stairway so that you do have a structural support. if that will work for your project. However, if it will not, and you have a situation like this, then you could either install a beam and maybe use some type of an inverted hanger at the other side, or set the beam on top of the post. And to do something like that, you would just simply miter the corner of this beam and this beam here, or look for another way to do that, so that you would have a nice solid structural support for the stairway. And instead of a beam, you could always add another 2x or another piece of lumber that would be the same thickness as your deck joist. And then you could nail the stringers through the back of the joist and add either some 1x or some 2x, maybe a 2x4 connector board like we have here, to connect the two boards together to again provide you with some structural support, along with some building hardware. And instead of using lumber, you might be able to use some hardware, maybe some straps, or even some thicker metal, 1/4 inch thick, that you might be able to use maybe one on each side, or even just one on one side, where you would drill some holes through the lumber and use bolts to connect the two boards together. And of course, you could always use a smaller board. I see this a lot. And even though a structural engineer might not approve something like this, I've seen every type of assembly in this video, built a variety of different ways that seem to work just fine. However, I'm also not about to suggest that all of these connection methods in this video will work for every type of outdoor project. And of course, the old plywood connector, I have seen this plenty of times, even though it's my least favorite in this video, because if this plywood delaminates or comes apart within a few years or even a few decades, I would hate to be the person who's using the stairway when it does. And in this example here, simply going to nail the upper section of the plywood to your deck joist and the lower section to the stair stringers. And I did draw a piece of treated plywood in here if that's going to work better for your outdoor deck. And of course, we cannot forget the building hardware, even though these are just simply straps nailed to the back of the stair stringer and to the front of the deck. Some hardware manufacturers do provide special types of building hardware to solve this particular problem. So that also might be another suggested assembly method you could use. And I would also like to point out that if you only have a few steps, maybe 2 or 3, 4 or 5 at the most, then some of these methods might work a little better than if you have a longer stairway, or a stairway that's going to be located in a high traffic area. That's actually going to require a stronger structural connection. And that's what we're going to be looking at here. And the last one in this video. And all I'm going to do here is run the stair stringer under the deck joist if the deck joist isn't too large. This might not work with a 2x12. And of course, if you do have a 2x12, you might not have this problem anyway. So if you are using 2x6 or 2x8 deck joists, then you might be able to use this method here. And this is one that I like because you can use the exterior fascia board or the front of the deck, sides of the deck, as the last riser. You're going to be able to nail the joist into the stringers, toe nail the stringers into the double joist, or end nail the stringers from the other side before you install this joist here. In this video, I will provide you with another idea for building a safer set of stairs over an existing concrete stairway that might not be safe, or a stairway that might need smaller risers. And to save you some time and frustration, this is not a step-by-step instructional video. This is more or less a video that will provide you with an example of how something like this can be done. And in this example, we are going to be adding a sideboard here. And it's going to provide us with the additional structural strength we're going to need to hold everything together and be able to lift the stairway off of or put it over the old existing stairway. So we have a stairway here with 3 steps, and we wanted to add another step so that we could lower the height of each one of the risers to make it easier for possibly an older person to walk up and down a stairway. So we're just simply going to design the stairway like this. We're going to have a larger board. In our example here, this is a 2x10. And all of the lumber is treated. I will leave it up to you as to whether or not you need to use treated lumber or other materials. And I went ahead and added a gravel foundation here so that we could extend the lower step. However, this might need to be concrete. You might need to bite the bullet there to have something that will provide you with a little more support. So not too difficult to build. However, something like this is probably going to trap debris, dirt, sand, and if this becomes moist for a long period of time, it can rot the lumber. But that's the beauty of this stairway. If you build it to where you can lift the set of stairs off, then you're going to be able to clean these areas. Let's go ahead and take a look at the nailing. You can use nails or screws and put them wherever you possibly can to fasten everything together. And that would include whether or not you're going to create something permanent or have something that you'll be able to lift off so that you can clean the debris that will get captured under the stairway. And the debris usually accumulates from any gaps or cracks in the lumber, any knot holes that might have fallen out. So keep that in mind while you are building. And make sure that you nail or screw everything together, including the back of this board to your boards here. And if you are going to build it and then install it over the stairway, it wouldn't be a bad idea to check it in sections. So maybe build these 2 sections together and then set them over the existing stairway to see if everything's working. And it might not be a bad idea to use screws on the sides. Maybe only put a couple of screws in on the sides and then set everything in place to make sure that it is going to work and you don't need to make additional modifications. I mean, the last thing you want to do for a project like this, if you've never done something like this before, will be to firmly attach everything together using adhesives, whatever, and then find out that you made a mistake and your new stairway isn't simply going to slide over the existing one. Next up, let's go ahead and take a look at an example of how you can simply lift the stairway off and then grab a broom and remove all of the debris. And you might want to do this once a year, once every other year. And of course, if the gravel is not going to work out for you, then add a structural footing that will provide you with some better support and or allow you to permanently secure your new stairway to the existing one. And if the stairway doesn't seem secure, you set it over the existing one and it's wiggling a little bit while you're using it. It doesn't feel like it's going to be safe, then you might be able to use some screws or some type of building hardware to attach it to the existing stairway. Now, another thing I need to point out is that some stairways might require a longer last step. And if this is going to be a building code issue, then you won't be able to use this particular idea. Now, another thing I don't think I would be happy with, but you might be tempted to use, would be some type of a design like this to where you use a larger skirt board or sideboard to create this design. And I don't see a problem with this as long as you're going to install a guardrail on both sides, something that will not allow people to jump over the side of the stairway. Because something like this could be a trip hazard as somebody comes down the stairs and then wants to jump off of this step here or this one here, and then of course gets their foot caught and then face plants into the ground. Not a good thing. And definitely something to think about before and not after building something like this. In this video, I will provide you with the basic information you're going to need to add a landing at the bottom of a stairway. Now, the first thing you're going to need to do will be to remove the first riser in some cases, or the first tread. Now, you won't need to remove these all the time. However, in our example, we are going to remove them and measure the height of the stringer that sits on top of the treated lumber. And if yours is not sitting on top of treated lumber, you can simply grab a piece of treated lumber, butt it up against the stairway, and then measure the distance. And in this example here, we have 5¼ inches. And that will be the height of our floor joist. So we're going to need to cut a 2x6 that is usually 5½ inches tall down to 5¼ inches, as long as we're going to be using a full 1.5 inch piece of lumber for our sill plates. Next thing, let's go ahead and draw the perimeter of the landing. And of course, your design can be different. Then we're going to cut our base framing plates, or the plates that our 5¼ inch tall lumber will be sitting on. Now, you can fasten these to concrete with some type of a wedge anchor, framing anchor like this one, that will require you to drill a hole in the concrete. Or you can also use some type of epoxy and all threads. And in some cases, you might be able to get away with using a shot and a pin. This is a type of nail that can be driven into the concrete with a tool that can usually be purchased fairly inexpensive or rented from your local rental yard. And if you are going to be attaching this to a wood framed floor, you can usually use nails or screws, and even put some type of an adhesive underneath the framing plate. And it wouldn't be a bad idea to position all of the pins or the framing anchors in a location where they will not interfere with your rim joist or your floor joist. And to give you a better idea of what I'm talking about, let's go ahead and install the rim joist on each side. And if for whatever reason you need to notch any of the framing components for the floor joist or the rim joist here, that's usually not going to be that big of a deal. But you can see here where all of the pins are located in an area where they are not going to be underneath any of the other joist or the rim joist. So if you can avoid that, make sure that you do. And you can fasten the joist to the framing plates with a toenail or an angled nail, usually a 16D. And I will leave it up to you whether you use a common or a sinker nail. And let's not forget that you might need to check with your local building department to verify whether or not you can actually make this modification to your property, as I try to mention in most of my videos. And of course, you can end nail the joist through the ledger with 16D nails also. I usually like to install 3 for 2x6 or 2x8, and then 4 for a 2x10 or a 2x12 joist. And if for whatever reason you're using a 2x4, 2 nails should work for that. And of course, the rim joist can be toe-nailed, about 16-inch on center spacing for the nails to attach it to the framing plates. And after you have secured all of the framing, you can go ahead and install the floor sheathing. And in our case here, we are using the same thickness, 3/4 inch thick sheathing, the same thickness as our treads. If you are going to use materials with different thicknesses, make sure that you adjust accordingly. For example, if I was going to use 1 1/8 material, I would need to lower this another 3/8 inch to prevent riser variations in the stairway or different height steps. And another thing you might consider doing will be to put an overhang in the area that will be used to step down off of the platform onto the floor. And that would look something like this. The same overhang that we have here will be the one that we are using on the stairway. 1 inch overhang for the stair steps, 1 inch for the landing. And you don't need to put this on the landing if you don't want to. However, the step down will usually look better if it matches the stairs. And obviously you will not need it in any area that will be up against a wall or a section of the landing that you will not be using to step down off of the landing. So if you're going to be able to step down off the landing in this direction and in this direction here, then you might consider using a 1-inch overhang all the way around the deck. Another thing you might consider doing will be to bring the landing out to where it lines up with either the first step or the front of a riser, if this will work better for your design instead of coming back a little bit and then over. And of course, consider making the landing a little shorter. If this landing was about 1 inch shorter, we wouldn't have this small piece here. However, that won't work out all the time, and you might need to make adjustments to the sheathing or to the joist. And of course, we can change the direction of the floor sheathing if that's going to work better for us along with the floor joist. And you can always add 1 or more of the base framing plates if you want to make the floor a little stronger. And I've actually done something like this when using 2x4 joist, if that might work better for your project. And for those of you who have noticed, we have cut the ends of the stringer off so that we could butt the joist up against the stringer. And again, another idea that you can use if that's going to work better. In this video, I'm going to provide you with what I would assume to be an easier way to build a stairway that's going to have a mitered design like this one here, where it does not go from point to point to point, in the same way that you would have a standard miter do. So we have a 90-degree angle on both of the designs, except we're going to move the miter over a little bit. And that's going to look something like this for a stairway that might be easier to build if you go from point to point to create a stairway with different sized stair steps. So we have 11 inches, and then we have about 17 inches over here. And if we built a stairway like this, we could run a stringer at an angle here. The stair stringer itself could be used to support the edges of the stair treads where the miter connects together. But that's not going to be the case on the other design, where the miters will be offset. And I'm not even going to suggest that you build this. However, for those of you who are, I'm going to try and simplify things. So again, you can see here where the miters are offset and still at a 45-degree angle. However, this is not going to allow us to use a straight stringer. So what I would suggest would be to position the angled stringer at a 45-degree angle to pick up at least one of the miters. But again, this isn't going to be required either. And if necessary, you can always change the angle of the stringer or add more than one center stringer and one stair stringer connecting into it. You might need to install another stringer over here, depending upon the maximum on-center stringer spacing for your tread materials. So we won't need to install any blocking here. However, we will need to install some blocking for the next step. And we're simply going to use a block here that's going to connect to another block, and then use 2 blocks here for the last mitered step. And again, you can get as creative as you want here. You can install the blocks differently, and you could even extend the length of this block all the way back to the front of the decking. So just keep in mind that you don't need to follow my example 100%, and you can get a little creative with your design. So again, the mitered angle for the stair treads where they're going to connect together now have some type of structural support for the stairway. And if you're going to build a longer stairway, might require additional structural support, stronger stair stringers, stronger stair treads, and additional bracing. In this video, I will walk you through the process of laying out a 6-step winder section of a stairway. And to do this in this example, we're going to start with a 6 foot by 6 foot square that you can lay out And the first method might not be necessary, but I'm going to show it to you anyway because this might be helpful for you. And in that method, we're going to take a 2-foot radius. You can change it and make it larger or smaller if it's going to work better for your project. And then we're simply going to divide this into 6 units. Or you can divide it into 3 units on each side of a diagonal line that will connect from corner to corner. And I'm not going to go into much detail on this because I think I've created an easier method and one that will not require you to do a lot of math. And that would simply be to measure over the distances that I have here for your 6-foot square, even if your stairway is only going to be 3 foot wide. And this method should work just fine when measuring out a variety of different stairway lengths or stairway sizes. And if you notice, this measurement here is the same as this one. This measurement here is the same as this one. And this one will be the same as this one. And for those of you who cannot see it, this measurement here is 1 foot 7 5/16 inches. This one here is 1 foot 10 1/4 inches. And this one here is 2 foot 6 7/16 inches. And after you have laid out these measurements, you can connect the straight lines from those measurements back to the center or corner of our square box. And then we are going to take a 6-inch square, and you can just do this with a framing square. You don't need to make a separate square for this. And then we're simply going to slide it over until we have it lining up with this point right here. And again, this can be done with a framing square, just simply lining up the framing square with the 6-inch measurement there. And I do have other videos on that at our website for laying out a variety of different types of winders that I would suggest watching also if this doesn't make sense. And then once you have this mark here, you can simply create a straight line up to this point right here where it intersects into this line here. And then square off of that and go back here, or simply measure the distance down here and then measure the distance up here and then square off of this line here until it connects and meets right here. And then you're simply going to pull off of this line here a measurement of 3 feet or whatever size you're going to need for the width of your stairway to provide you with the desired layout you're going to need. So this one right here is 3 feet, and we're coming off of this point square to create a square inside of our winder stairway. And if I want to make it wider than 3 feet, then all I need to do is extend these lines outward a little further and then move these lines over. And before I do that, I just kind of wanted to point out here that most building codes require a 6-inch minimum distance here. And since that is the minimum distance and they can be larger, you're probably not going to have a problem with these measurements here. However, if you are, you can always change this to a curve to create an equal measurement all the way around for each individual step. And if we wanted to make the stairway 2 foot longer for a total of 5 feet, we can just simply move this line over around the perimeter like we did here to create a 5 foot wide winder type stairway with 6 steps. And hopefully that makes sense. And again, I think you can use the measurements that I have here for the 6-foot square along with the instructions in this video to lay out a stairway with this type of design. In this video, I will provide you with a way that you might be able to use to figure out the overall total rise in a stairway that you cannot just simply grab a measuring tape and measure from the upper level to the lower level because you might have other obstacles in the way preventing it. So let's go ahead and jump into this. The first thing you can do will be to simply grab a level and draw some level lines around the walls if this will work for you. I'm not about to suggest that something like this will work all the time, because you don't want to have a line going all the way around your wall. And if that's the case, you don't want a line going around the entire wall. You might be fine with using a level and then just making a mark at the corner, a small mark that you might be able to remove. And I've even made marks like this with a knife, just a little teeny slit that most people are never going to see. And if you need to use a straight edge, a straight board, because your level isn't long enough, then you can always use something like that also. Straight edge or a long board or a longer level. And again, you're going to end up doing the same thing, putting a mark in the other corner. And of course, from this point here, we will grab another straight edge and the level, and then go ahead and make another mark. And of course, this mark right here will be the mark we're going to use to figure out the total rise, or the difference between the lower level and the upper level. And of course, that method will work if you don't have carpeting. If you have carpeting, it could create another problem. And you might even have a difficult time figuring out the exact total rise, even if you use this method here. So what I'm suggesting here is that you create some type of a component that you can attach to the carpeting, something that will provide you with a firm and secure attachment. And to do this, you could grab a scrap piece of plywood and then screw it into a 2x4 to create some type of a platform like this that can also be screwed and attached to the flooring. And I'll leave it up to you as to how many screws you use. And usually screws can go through the carpeting without creating any problems. However, if this is going to create a problem for you, then I don't suggest using this method. And of course, all you need to do is have the 2x4s a little taller than the top of a landing or the next location that you're going to use, so that you can level across to create the first section of the total rise. And of course, this mark can be anywhere here that is lower than the top of this 2x4 or this particular board. And you can always set the level on top of this board also. And of course, the main thing we're trying to do is create level sections that we can measure later. So after we have created a level line here with our level, we can simply mark this 2x4 to create our first leg or our first measurement line, and then simply work our way up the stairway. Like I said, you can put the level on top of it, or I could have this a little bit lower, just as long as I'm creating level sections that I will be able to measure later to figure out the overall total rise. And again, with carpeting and padding, you could end up with a small variation when figuring out the total rise. And of course, all we're going to do here is measure from here to here, and then from here to here, and then from this point here to the top of the carpeting, and then add each one of these measurements together to figure out the total rise. And if you don't like either one of those ideas, you can create a water level and simply hold one end of the water level up, even or flush with the top of the flooring, and then simply work your way over to the other side where the water level can be marked, and then allowing you to measure from this point to this point to figure out the overall total rise for your stairway. That can be used later to figure out the individual riser heights for each step. And in my opinion, if you're looking for accuracy, something like this is probably going to provide you with the best method, especially if your levels are not perfectly level. So keep that in mind also. Check your levels to make sure they are working correctly before using them and finding out that you're a quarter of an inch, a half inch, or even an inch off when trying to figure the total rise for your stairway. In this video, I will provide you with a method you can use. Keep in mind, it is not the only method that you can use to raise a stairway. However, it is one method you can use if you have lumber that is rotted underneath your stair stringers, underneath the bottom of your stairway, and it's sitting on top of a wood frame deck. And in order to do that, all you need to do is build something like this, something that you could use to raise the bottom. And I'm providing you with two different situations here. If you have a deck that goes all the way across, you can just use this method on both sides. And something like this will simply attach to the stairway. You're going to attach a board like this to the stringers, and this could always go on the inside of the stairway if that will work better for you. And we're also going to attach some type of a support board to this 2x4, and this can be a 2x4 if your stairway is not very big. If not, you might want to use something larger, 2x6, 2x8, 2x10. And we're going to do the same thing over here. We're going to attach this board to this one, this board to this one, and this board to the other side of the stringer, so that the bottom of each side can be raised enough to where we can slide another board underneath these boards here. And it's usually not going to require a lot to raise a small stairway. I've actually lifted them up before and put a small piece of plywood underneath the main support board. However, if you need a little more strength, grab a jack, raise one side, and then put your shim material underneath the support board, then move it over to the other side, and then raise it a little bit so that you can do the same thing by installing the shim. And I don't know why you would need to raise this over 3/4 of an inch. However, you might need to, depending upon how difficult it will be to make the repairs or to remove and replace any damaged materials. And if you need to, you might be able to leave the entire stairway intact and then cut at the bottom, cut at the top, and then lift the stairway out and set it aside, then make the repairs if that's going to be easier for you. Now, the reason why I don't want you to raise it too much is because we could end up with a gap over here. If you raise it, then it's going to be tight at this point here. However, this could separate, and if it separates enough, when you go to lower it back down, you could pull the stringer away from the head out or the top of the floor framing. And in our example here, we've only raised it 1/4 of an inch, just high enough so that we could remove the damaged decking board along with the damaged lumber in the stringer. You can cut a notch out like this, or you can just simply cut this section of the stringer off if you still have enough support on this side to structurally support the entire stairway. And you can always do the deck repair first. Repair the decking and then lower the stair stringers back and then reattach them to the decking. Then you can go ahead and make the stair stringer repair. And this is actually the order I would go in to make this type of a repair. So after you've removed the damage, you can go ahead and replace it with a new board. And that might look something like this, where you attach another block on the other side. And this block can also be used to nail or screw the stair treads into if for whatever reason the top of this board is damaged. So here is another video request from one of our viewers, and in it we will be providing you with some design ideas, not construction assembly ideas, for anyone who might be dealing with an angle, something that is not going to be 90 degrees at the top of your stairway. And of course, in this example here, we have a stairway that is going to come 90 degrees off of the floor. And the stairway, treads, everything. So here we have a standard construction assembly and design. That is not going to be the case if we move this wall and the stairway 22.5 degrees. And the problem I see with this particular design is the fact that the steps will not be the same size. And before building something like this, make sure that you would be allowed to build it in your area. Check with your local building authorities and building codes, because I don't think you would be able to just simply fill in this area here to create your last step. However, I would also like to point out that some building code officials allow for variations like this under certain special circumstances. And if yours falls into that category, then you'd be allowed to build it. I also don't think you would be allowed to build something like this because you're not going to have the minimum distance required for your landing or your step. And most steps require a minimum distance between 9 and 11 inches. Now, something like this might work because you now have a landing at the top. It will work if you have the minimum measurement, minimum distance required for the depth of the landing, and that's usually going to be 36 inches. It's got to be 36 inches or larger, and you might not have the room to build a stairway like this. It will depend on if you can move the stairway out a little further. And of course, something like this probably won't work either, but by reshaping the wall framing, you could actually create the 90-degree angles that we need to do something like this. So we would simply add another step to the stairway to where we have a landing that would be flush or even with the upper floor. And in a situation like this, the door could either swing in or out. However, this wouldn't be the case if you were to build it to where the last step was going to be here, because most building codes don't allow for doors to swing over the stairway. It can swing over a landing. It just can't swing over the stairway. And of course, that would look something like this if you had a wall on each side. And I believe that was the example that the individual who asked this question originally had. They had a situation like this. And in my opinion, if you can possibly remodel this area and you have enough room for a stairway like this, then this might solve your problem. And of course, the last suggestion that I have would be to redesign the stairway. And that, of course, will depend upon the design of your project. Here is another question that one of our viewers had. They wanted to know what the maximum angle could be for a sloping riser. And according to one of our popular building code books, it is 30 degrees. I will put a link to this particular building code. I'll provide you with a reference number and the building code book it came out of in the video description area. So 30 degrees, and that will be from the bottom of the nosing. And in this example here, the farthest protruding point forward that would represent our nosing would be right here. We could take our 30-degree angle from this point here. However, in this example here, we would need to lower that a little bit. If we had a nosing that looked like this, we would need to come from the bottom of it. And if we look at the measurement here, we're about 2 11/16 inches away from the vertical measurement coming off of the front of the stair step. And in this one here, we're about 4 1/16 inches with a 7-inch rise and a 10-inch tread depth. And of course, this measurement will get longer if the risers are taller and will become smaller as the risers decrease in height. And I don't think that the length or depth of the tread is going to affect this at all, as long as each one of the treads are the same size for each step in the flight of stairs. And of course, the most common angle you're going to find, and I built hundreds of stairways like this, is going to be around 8 degrees. And that's going to be a 1-inch undercut or a 1-inch increase in depth of the stair tread due to the angle of the riser on each one of the steps in that particular flight of stairs. Here is another interesting question from one of our viewers, and something that I always thought about myself. And even though I don't know if I can provide you with the exact interpretation of this, I am going to provide you with what I found in one of the building code books about exactly how far one of these steps can slope. And to make things as easy as I possibly can, I'm going to start with a 4-foot wide stair tread, or something that is 48 inches, because the maximum slope is 1 unit per 48, or a ratio of 1 to 48. and that's 1/4 of an inch per foot. And to make things as easy as I possibly can going in the other direction, I am going to make each step 12 inches in depth. And of course, in this example here, we have a stairway that is level and square in each direction, suggesting that each step has the same riser height and tread depth, along with the width of 48 inches. So let's go ahead and slope this baby 1 inch. So again, a unit of 1 inch in 48 inches is the maximum distance a stairway tread can slope. And of course, now would be a good time to point out that even though you might be able to slope your stair steps, that a stairway like this won't meet the maximum riser variations of 3/8 of an inch per flight of stairs. So if I lower this an inch, I'm going to have 6 inches here, 7 inches here, and 7 inches on the other side, 7 inches up at the top, creating a problem for our riser variations. Now I do have more information about that at our website in the building code section. So check that out if you are going to be looking for more information. So again, a stairway with this particular design won't work because of the riser variations. And in our next example, we're going to slope the stairway to the right, again, 1/4 of an inch per foot. And something like this might have a problem at the bottom, where we have a low riser again of 6 inches and 7 inches going around the rest of the stairway. However, there is a building code that might allow this to work, so I'm not going to rule this one out. However, something like this will if we take and slope each step in this direction, and we often do this when installing waterproofing, some type of a waterproof coating over an exterior stairway to allow the water to drain off of the stairway and not accumulate in any spot on the stairway to create a problem for people using the steps when or shortly after it rains. So again, something like this should work just fine according to this particular building code. Now, what if we take one step and slope it 1/4 of an inch per foot while keeping the rest of the steps level for this particular design? And I don't see a problem with this, because if we slope this 1/4 of an inch per foot, then we're still going to have a 7-inch riser, 7-inch riser, and a 6 3/4 inch riser. And even though this particular stairway might be approved by your local building department, it's not going to be a safe stairway to use. You could see how it could offset someone's balance and create some type of a trip hazard. And of course, here's another example of a stairway that won't be meeting local building codes because of the riser variations. So even though I might be allowed to slope this 1/4 of an inch in this direction, and slope this one 1/4 of an inch in this direction, and slope this one here 1/4 of an inch per foot in this direction, you can see again where we're going to have problems with the maximum riser variations of 3/8 of an inch per flight of stairs. And hopefully this makes sense. I would also like to point out that I have never installed a set of stairs with any step or landing sloping in this direction or in this direction, so sloping from right to left or from left to right. However, I have built plenty of stairways where the steps have sloped in this direction here and no more than 1/4 of an inch to allow water to drain off of the stairs if there is some type of waterproof coating that is going to be installed over them on an exterior stairway. Here is another stair building code you should familiarize yourself with, and I will put the reference number to that particular building code in the video description box so you can go check it out. And of course, the building code that I am referring to will have something to do with the curve or a bevel that might be located on the front of a stair tread. And don't be surprised if you come across any building products, especially products for masonry construction, that are used for stair treads when they shouldn't be. Now, the building code refers to a 9/16 of an inch maximum radius. So the radius would be the measurement from the center of a circle to the edge of the circle or the perimeter of the circle and would look something like this. So this is the maximum. It can be smaller, it cannot be larger. Unless your local building authorities, people who provide you with the building code information in your area, suggest otherwise. So always check with them before building your stairs to make sure that you can or cannot use the information in some of these videos. And of course, here is the maximum curvature. Let's go ahead and take a look at the maximum bevel. And since the bevel was not stated in the same way as the curvature, I'm going to go out on a limb here and assume that they're talking about this measurement here that cannot be longer than a 1/2 inch. And since they are referring to a bevel, I would imagine that you could shape this bevel in a variety of different ways with a variety of different angles, as long as this measurement here is not more than a 1/2 inch. And of course that bevel would look something like this. And no, I would not suggest using a curve and then a bevel and then a curve. Use the same design for each one of your steps to avoid confusion. And as I mentioned earlier in the video, I came across a radius that was probably about 2 inches when watching another video about someone building stairs in what appeared to be England, where of course the building codes might be different. So again, a bevel not longer than a 1/2 inch, a curve with a radius that is not going to be more than 9/16 of an inch. Here is another video that is inspired by some of the videos that I have seen on the internet, one especially. And even though I will not be providing you with any details about the video, it has inspired me to provide you, the viewer, with something you might not want to do. And that would be to use individual footings or small blocks, bricks, you name it, underneath your stringers. However, I would also like to say that I do understand why someone might do this, especially if your ground freezes in the wintertime and causes frost heaving or forces sections of your concrete footings to rise or raise above the ground. However, if I was going to build something like this, I still don't think I would use small individual footings that don't go into the ground deep enough. And I think the project I saw, it looked like they poured the footings after they set the stair stringers, but I'm not sure. Here we have a set of stairs where everything is nice and straight. And then maybe in a few years, you end up with some of the stringers and the footings either sinking into the ground or raising above it, creating a situation where you no longer have, in my opinion, a safe set of stairs. And this problem is going to get worse the further you space the stringers apart. So here we have them spaced about 16 inches on center. Here they're spaced 24 inches on center. And depending upon the size of the footing, you could end up with them tilting to one side as the soil erodes from underneath one side of the footing. However, I can't end the video without providing you with some type of hope, and that would be if you're going to use a 2x, maybe a 2x6 or a 2x8 for your risers, and you firmly attach them to your stair stringers, then these can actually act as structural supports. And even if you do end up with a couple of the footings sinking into the soil, or rising, the stringers could actually provide you with enough structural support to prevent the stairway from deforming too much. So keep that in mind if you are going to just simply place a few blocks or pavers underneath your stair stringers because you're trying to save a few dollars or you're dealing with another problem that I didn't mention in this video. And that problem might actually be the fact that you just don't have enough money. You need to save a few dollars here and there. Then I get it. Just be prepared for problems in the future. And maybe a helpful solution to that would be to use screws for everything so that you can unscrew some of the treads and risers so that you can access these areas for easier repairs in the future. In this video, I will provide you with an example of something that could create a headroom problem if you have a set of stairs above another set of stairs and you're already dealing with something that is at the minimum or close to the minimum headroom height allowed by your local building codes. And this is actually something that was brought to my attention by someone who was removing and replacing a stairway above another stairway that went into a basement. And it's really not too difficult to understand how you could affect the headroom height. Let's go ahead and provide you with an example of what the headroom height would be for this stairway. And that's usually going to be a vertical measurement from the front of the stair treads, going from the farthest projection forward off the front of the stair nosing or stair step all the way to the top of the ceiling, or in this case, the bottom of the stairway. So let's pretend like this measurement here, this area represents the minimum stair headroom height for a stairway. And if our new stairway is going to be moved forward, we're actually going to increase the height of the headroom. And in this example, we moved it backwards, or in this direction here, and reducing the height of our headroom clearance. However, if we leave this one in its current spot and move this one in this direction, we're going to have more headroom. And the opposite would hold true if we move the lower stairway forward in this direction. However, this is not what originally inspired this video, because the individual was going to build a stairway that was going to be wider. And as you can see here in this example, this would reduce the headroom height. And in our example here, I increased this distance by 4 inches, and it's going to affect our headroom height by 5 inches. And I would imagine this is going to be a big problem because most people are going to be replacing the old housed stair stringer type stairways. And I'm guessing they built millions of these types of stairways that went into your basement, and millions more that were above the stairway in the basement. Next up, let's go ahead and take a look at what you're probably going to be dealing with. Smaller steps and taller risers. And you're probably not going to have the room to make them longer. However, if you do, and this seems to be a big problem, I get a lot of viewers requesting information on this. And I've already made quite a few videos explaining it a variety of different ways. This is just another one that I hope will make a little more sense, because most of the time, the individuals who are asking me how to solve this problem want to install a longer stairway, a stairway with longer steps and shorter risers. And hopefully by now you know exactly what I'm going to say next. We're going to end up with a headroom problem here unless you replace the upper stairway and create the same stairway or something that will provide you with a safe headroom ceiling height for your project. So again, if we move the stairways in different directions, or if we make them longer or shorter, or make them thicker and fatter, we could end up reducing our headroom ceiling height for the stairway, which in turn would create building code problems and make the stairway difficult for taller people to walk up and down. If you work in construction long enough, you are going to hear terms used by other builders, architects, engineers, and construction workers that you might not be familiar with, and these are a couple of them. If you are building a set of stairs or talking to an architect or engineer over the phone, and they use the term carriage or horse in a sentence that might sound something like this: we are going to need to use 2x12 for our stair horses, or this set of stairs will require 4 stair carriages. Then at least you won't have to look this up in a dictionary, because all they are referring to is the stringer. And even though you're probably not going to run into this very often in your area, there's a good chance you're going to run into this while watching other videos or talking to other people who live in different parts of the world about building stairs and construction. This video will be the first in a series I'm planning on doing to provide viewers with product information. This is something that has been requested for quite some time, probably since the day I started my channel. So let's go ahead with the first one, and that will be to provide you with a variety of different adhesives you might be able to use when attaching wood to wood in the situation where you have a tread connecting to a stringer. Or if you have a situation where you have a wood finished tread, like an oak tread, that needs to attach to plywood or OSB. And the first thing I need to point out is that if you are dealing with lumber that is going to shrink or expand and contract, like most construction standard lumber, plywood and OSB might not fall into this category or might not expand and contract as much as construction standard lumber. I've seen 2x12s shrink from 11.5 inches to 11.125 inches. And if you're using 2x12 for your stair stringers, which is probably the most common lumber used, you could end up with a gap between the tread and the stringer. And if you're using glue, you're using an adhesive that is not flexible or allows for movement, then it will actually separate and either stick to the stringer or the tread, providing you with a gap between either the adhesive and the tread or the adhesive and the stringer. Because as the stringer contracts or shrinks, it's going to pull away from the tread. So again, if you're using construction adhesive that is not elastic or flexible, then there's a good chance you're going to end up with your stairs squeaking. So what I would recommend would be to find a product with polyurethane in it. Now, I could swear that I used to use a product with polybutylene in it. However, since I couldn't find any products with polybutylene in it, then I have to figure out that I probably made a mistake and that it was actually polyurethane that I was referring to. Now, what I used to use was a window and door sealant, and they do not sell this product anymore. And it worked great. We used to use it on all of our floors and our stairs. And since that product is no longer available, I will not be able to provide you with its product information. However, I will list a few products in the video description area or in the comment area, along with a little more product information when it becomes available. So make sure that you check out our video description area if you're looking for more information about adhesives that will reduce stair squeaking that should work for your project. Here's a problem that one of our viewers ran into, and I understand it's not going to be a problem that most of us are going to be dealing with, and that will be the walk line. The walk line is usually going to be 12 inches from the inside of the stairway. This would be a curved or a winder stairway, and since this particular stairway has steps that are exactly the same size on the inside, on the walk line, and on the outside, then we're not going to have any problems with the building codes. So again, that would be for a stairway like this, a curved stairway with the same sized treads on each step. However, that's probably not going to be the case on a stairway like this. I'm not about to suggest that you can't design a stairway that will have the same walk line throughout the inside of a stairway like this. However, you're not going to have it on the other side, suggesting that this is a stairway that is probably not going to be approved by most building departments, where you're not allowed to have more than 3/8 of an inch variation in the walk line. And hopefully this makes sense. However, if it doesn't, because you're not wrapping your mind around the fact that people aren't going to walk along this side of the stairway all the time, they're going to be walking up this side also. Right here we have a big problem between this step and this step, and I really don't see any way around it to create a stairway that would work with this particular layout. In this video, we will take a look at what I've noticed to be the biggest problem when covering stair stringers with deck tape. and other exterior stair building projects, and that's the fact that they somehow cut it into 1.5-inch strips or buy 1.5-inch wide deck tape and use it for 1.5-inch wide stair stringers. And what happens with this is that the water can actually enter into the area underneath the deck tape and on top of the stair stringer. So to fix this, all we need to do is simply use larger pieces that will fold over the sides. So for example, a 2-inch piece of deck tape is probably going to work better for an 1.5-inch wide piece of lumber. And in this example here, I'm just providing you with what it would look like on one side of the stair stringer. You're going to need to have it go over both sides. And it wouldn't be a bad idea to also go over the front of the stair stringer. And even though this won't prevent water from absorbing into the side of the stair stringers, by folding it over, it will allow for the water to stay away from the top of the stair stringers. Next up, let's go ahead and put some caulking at the back. We've covered the sides and the front, but we could still have water absorbing in from the back here. So maybe some caulking, some type of a sealant might work. You can put the sealant on and then put the tape on, or put the tape on and then put the sealant on, whatever you think is going to work best for your project. You don't want to seal the entire top of the stair stringer and then allow water to seep in from the back here, especially if your goal is to keep as much water off of the top horizontal sections of the stair stringers as possible. And last on our list, besides covering the entire stair stringer, would be to cover the risers with your deck tape. Just keep in mind that water leaking down will be able to get behind these areas. It won't be as easy to keep the water out of the vertical sections as it will be to keep it out of the horizontal sections. And I know some of you are going to suggest using treated lumber. Go for it if that's going to work better for you. And don't forget that you can paint or use other wood sealers to prolong the life of your stair stringers also. In this video, I will provide you with the angles that you can use to lay out and build winder stairs. So let's go ahead and get started with the first one, where we have a line connecting at both ends of a square and is a 45-degree angle. So one step in the landing. 3 steps will have a 30-degree angle. So each step from this point here, 30 degrees, from this point here, 30 degrees, and then 30 degrees. And of course, that would be coming from the center point here. Next up, for our winders with 4 steps in a square for our landing, we're going to have 22.5-degree angles. And since 22.5 is half of 45, you can again draw the straight line down the middle for your square. A square, of course, is going to have the same measurements on each side. And in our examples here, we're using 4 foot. And even though I'm providing you with the angles for these winder stairs, you will need to check with your local building department to verify whether or not you can build them, especially this one and the next one, where the steps are extremely narrow and might be unsafe to use, where the steps are extremely narrow and could be difficult to use. And for our last example, a 5-step winder stairway will have an 18-degree angle. And again, that will be from the center point. In this video, I will show you how you can use tape to lay out the lines for your grippable hand railing. And you might not need it for a situation like this, or a situation like this up here, but you might need it when you get to an area like this that you might not be familiar with. And I actually got the idea from someone who suggested that you can use a string for this. So if that will work, then try that also. And I think the best way to go about it would be to cut a board at the desired length you're looking for either the bottom or the top of your hand railing. And then get the board in the plumb position so that you can figure out where to place the tape. And of course, the reason why you're using the tape is so that you don't put any pencil marks on the walls. And you can put as much tape as you feel like you need on the walls. If 2 or 3 pieces is going to work better than something like this, then go for it. Just make sure that you are using painter's tape, something that is not going to peel the paint and your texture off of the walls when you go to remove it. And since the key positioning points are going to be from the front of the steps or the corner of your landings to create a continuous handrail, then you're simply going to position them something like this. So again, here we have the front of the step. We're plumbing our board to create a vertical line and positioning the tape where we need it so that we can basically connect the dots to create our handrail layout lines. But I'm going to go ahead and remove these layout lines because this isn't what we're going to have. We're going to have something that looks like this. Then we're going to create our layout lines by simply connecting the dots with more tape. And that's the beauty of this. If you don't like the design, you can simply reposition the tape. And if the line you laid out was for the top of the handrail and you needed the line for the bottom of the handrail, then you could simply lower the lines and reposition the tape for that also. And again, the complicated areas, something like this that might be a little confusing for you. Or you might want to put a curve here instead of having it miter in at a corner. Or you might need to move this a little further forward or a little further backwards, or you might need to extend this a little further down. And for a situation like this, you could just simply run this tape all the way down and then do some measuring to see if that would work. Instead of having a 90-degree angle here, you might be able to run the hand railing and connect it with a miter joint here. And of course, if we have a winder set of stairs or a curved set of stairs, for example, if we add a step to the landing, then we're going to create another situation for the handrail that we might not be familiar with. And that's where using the tape really comes in handy. It provides you with a visual idea of what the handrail should look like, and in some cases will provide you with an excellent way to locate all of the handrailing hardware that you're going to use to attach the handrail to the wall framing. In this video, I will provide you with another project that you might be able to build without a lot of complicated math or calculations. And we're simply going to have a deck with 3 steps. And the beauty of this is that you're going to be able to use 2x6 or 2x8. However, with this design, we might have a problem with the building code that requires a 4-inch sphere or a round ball to not be allowed to travel through any part of the stairway. And we're going to be at 4 inches here. If I have a 2x6 and then I put an 1.5 inch thick decking board on top of that, I'm going to be right at 4 inches. And if I use 2x8 for something like this, I'm going to be over 4 inches. And I'm also creating this design here to sit on top of soil. And I'm not about to suggest that these bottom boards won't rot. And I will leave it up to you if you need to make further modifications to this to meet local building codes or work in your area. Another good thing about this design is that we are not going to have any mitered corners. Everything is going to be a 90-degree angle. And that's going to make this project a lot easier to build also. And to calculate the lengths of the boards we're going to use for the smaller stringers, all we need to do is draw a straight line down here and then measure each one of the boards from that straight line. And that's going to give us the length of each board for these smaller stringers. So in other words, this board right here will be the same length as this board. This board here going back to the line will be the same as this one here. And I know that might seem confusing, but let's go ahead and motor on and continue with our tour here. Don't forget you can stop the video at any time. And of course, watch the video again if you miss something or if something isn't quite making sense. And don't forget that you can modify this design, like I mentioned earlier, by installing additional bracing, blocking, and structural supports. And you can connect each one of the 2x6s together with building hardware like straps or flat framing anchors, even blocks. Just make sure that you install some of these framing anchors on each side. If I was just going to install all of these framing anchors on this side, along with the straps, then it might allow the 2x6s to fold over at the breaks or where the 2x6s are going to be connecting to the other 2x6s. So we're going to need to install some type of support bracing on both sides. And another idea might be to use a block. And if you put the block in between two boards here and then attach it with screws or nails, something like this here on both sides, then you might be able to use that instead of something like this. And you might even be able to use dowels to fasten these together. And don't forget to check out other types of framing hardware that you can use to create stronger stair stringers. And to figure out this length here, we're simply going to lay out some of our decking boards until we get the desired width that we want. If you want to cut one of these in half or cut it down to create a specific shape, then go ahead and do that. I'm not doing that. This deck, to meet most building codes, needs to be 36 inches long or 36 inches wide here. And to get that, I think 36 inches is right about here. I made it a little bit longer. You can't make it shorter, but you can make it longer. And if we use this method here, we're going to be able to create a deck that doesn't have shorter boards in it. Our deck's going to look nicer, at least in my opinion. And we're going to do the same thing with our stair steps. 2 steps with a 2x6 is going to give us about an 11-inch wide step. And it's going to be important to keep all of our stair steps the same width or depth going in both directions. So if you can see here, we're just simply raising this step up here. And I'm going to do the same thing with this step here. And finally with our last step here. If you notice, I've created a flat section here. And we're going to use each section here to calculate the lengths of our decking and stringer boards. And this is the beauty of this right here. This really makes your job easy. And make sure that you figure out the width and the depth of the deck before you get started. So in other words, you might not need to cut any of these boards. For example, if I had 10-foot 2x6, I could lay the 10-foot 2x6 next to each other, put the desired gap in between each board if I'm going to have a gap in between each board, and then grab my measuring tape and measure the distance. And if I want to make this distance here the same as this distance here, so that both the width and the length or the depth of the deck will be the same size, then I can do that. And it wouldn't be that difficult to lay out your boards in this direction here with the desired gaps if you're going to have them, and have them run full length to get these measurements here. So the measurement for this board right here is going to be the measurement from right here to right here. The measurement for this board right here, this step, this 2x6, the second one down, is going to be measured from right here to right here. And this board here is going to be the measurement from the front of this right here all the way to the back. And you guessed it, this measurement here all the way from this point to this point is going to be the measurement of our bottom board. And now would be a good time to point out that the bottom board will need to be ripped down and made a little bit shorter. What you're going to do is take the height of the decking. 2x6, we're going to have 1.5 inches thick 2x6. We're going to subtract 1.5 inches off of the bottom board. So if we have a 5.5 inch wide 2x6, we're going to rip that down to where it's 4 inches wide. And that's going to allow you to make each riser height the same size. So again, these lower boards, all of them are going to be 1.5 inches shorter if we're using 1.5 inch decking. If I'm using 2-inch thick decking, then I'm going to subtract 2 inches off of my 2x6. And I won't be going into a lot of detail about that in this video. However, I do have plenty of other videos at our website. Make sure you check them out if that doesn't make sense. And in our design here, these are not going to be the same size because the width of this is shorter than the length. And you can see it right here. If I wanted to make this length here the same as this length here, then I would need to cut these boards a little shorter. For example, if I have 3 foot 3 1/4 inches as a measurement from here to here. I've figured out how many decking boards I'm going to need according to my local building code. Got to be bigger than 3 foot. Then the same is going to hold true for the width. I could simply cut these boards here 3 foot 3 1/4 inches to create a square landing, or a landing with the same measurement for the width as it would be for the depth. And that's going to change the measurement of some of our boards. And I could always make this 4 foot wide and this 4 foot long also, if it's going to work with our decking. And hopefully that makes sense. However, if it does not make sense, then feel free to let us know in the video comment area any questions you have about this, or if there was something I didn't mention, or if you have a better way, then feel free to share that with us in the video comment area. Here is another quick tip for those of you who are cutting your stair stringers and a section of the stair stringer breaks off of your $40 or $50 piece of lumber and you're not that hip on getting rid of it. And you don't have to. Simply put some adhesive on both sides that need to connect together, place it back on, then grab some small nails and reattach the broken tip back to the stair stringer. And I've done this hundreds of times with great success. And of course, you're probably not going to have this problem if you're selecting primo lumber, number 1 or a select grade of lumber for your stair stringers. However, there are a variety of other circumstances that could lead to this. And if you can save the lumber using this trick, then definitely use it. In this video, I'm going to point out a suggestion for a handrail for this type of stairway. This is basically something that one of our viewers was having a problem with, and basically creating a doorstop for the door. So if I zoom in, I think I got a picture of it here. You can see right here, there's a spot on the door that is hitting the handrail. It's basically acting as a doorstop. And I can see right here that the door isn't going to fully open. It's never going to fully open again because somebody put the handrail in the way. And I see stuff like this all the time. And I'm not about to suggest that it's inexperience. Because of local zoning or property line measurements, building can't come out any farther. Then you wouldn't be able to extend the wall and then just have a straight handrail here. However, if you could extend the wall, you could extend it on both sides or extend it and then use this method here for your handrail. And of course, at the top of the stairway like this, we're going to have a landing and a door entrance into the building, along with an easier way to create a safer handrailing system. Something that's going to be easier to install, easier to build, and easier for the people who use the stairway to use. And if you don't like that idea, you could always install something like this. Remember, most of the time we only need a grippable handrail on one side of the stairway. And if you remember in the picture before, the handrail came down over here. Who's going to walk up the edge here and fumble around with the steps right here and then turn and walk up? And I get it, if you have to, you still have a safety problem right here. You don't have a safe place for someone to turn and walk up the stairway. Where with this situation right here, you're just simply going to start here and walk up the stairway. And if you need to direct traffic, you don't want people coming up this side here, then you could always install some type of an obstacle, plants, potted plants, or something that might even be installed permanently that you won't be able to move for the purpose of redirecting traffic more towards the center of the stairway, and try to avoid the sections of the stairway that might not be safe. And this probably won't need a guardrail on each side because we're not over 30 inches in height. However, you would need to check with your local building department to verify whether or not you could use any of these methods I mentioned in this video. Here is another thing you can do when you are building stairs, and you would actually like them to turn out as nice as they possibly can, and that would be to stack your stair stringers on top of each other before they're installed so that you can check for any imperfections. And to do that, you're either going to line the back of it up, you're going to line the front of it up, Because if your imperfections are only about 1/16 of an inch, then I wouldn't even worry about it. What you're going to be looking for will be imperfections that are going to be a little bit larger. So here you can see where everything looks good, and you've done a good job cutting your stringers at the top. And again, if this was off just a little bit at either the bottom or the top, then you can probably let it go. However, if it's off quite a bit, then you're going to need to make some adjustments to it. Or at least I would recommend that you make some adjustments to it. And you can do that by adding shims or shaped strips of lumber like we did here. And I would recommend using some type of an adhesive along with some small nails or screws to attach the shim to the stringers. And I will be making a future video to show you what happens if you don't fix this before you install your stair stringers. So here we had some imperfections that needed to be filled, and we used shims to do that. However, you could end up with an imperfection like this that needs to be trimmed. And if that happens, just simply grab your saw and recut that part of the stringer, or use a planer or some type of a sanding device to trim the wood off. Now, I've also used belt sanders to flatten some of these imperfections out also. And the last thing I would like to suggest would be that if you have too many imperfections, then you might consider recutting the stair stringers. In this video, I will provide you with a couple of methods you might be able to use to repair a bracket type stairway, where the bracket might be loose because part of the stair stringer is rotted. And this could be from termites or dry rot, some type of moisture problem, or even the fact that the stairway hasn't been maintained or painted and sealed properly. And keep in mind that some of these methods can be used for more than one bracket. And of course, if the damage is beyond repair, make sure that you replace the stringer. So let's go ahead and start with our first suggestion, and that will be using a larger bracket. You could make your own bracket or purchase something that you might be able to use to where you can relocate the lag screws or bolts, whatever you're going to use, to reattach the bracket to the wood stair stringer. Another method that might work for you would be to install some type of additional lumber. And this could be a 1x4, a 2x4, 2x6, or anything else that would allow you to reattach the bracket to the wood stair stringer. And I realize some of you are worried about covering the wood rot, and I don't blame you, or termite damage, and I'm here to tell you that I'm going to have to leave that up to you, because sometimes when you cover wood rot and you don't treat it or seal it somehow or remove all of the wood rot you possibly can, it could still remain a problem. The wood rot could get worse. Same with the termite damage. And again, something to think about. Next up on the list would be to use a larger piece of lumber. Again, this could be a 2x12 or 2x14, and it can be shaped to fit the stair stringer and even beveled up here, as you will see in the next example. And you could always install some type of an adhesive in between your new board and the stringer. And yes, you could use treated lumber if that's going to work for you. Just make sure that this gap right here is sealed and maintained, because if there are any cracks or gaps there, you're going to allow moisture to get in between the two pieces of lumber. And again, that could accelerate the process. And for those of you wondering why I'm even showing this, it's because I've seen people use these types of repairs incorrectly and on stringers that should have been replaced in the first place, instead of doing any repairs like I'm suggesting in the video. And in our final method, you might choose to drill some holes all the way through the stringers to reattach the brackets to. And keep in mind that this method here might work just as good without this board, depending upon how much damage you have to the stringer. And of course, the bevel I was referring to, a bevel like this could prevent someone's shoelaces or parts of their clothing from snagging here. And this could also be a problem for other repairs I've already suggested. You might want to bevel or round off the corners on some of these pieces to prevent any type of safety problems. And another thing you're going to need to do will be to reduce the length of the stair tread by the amount of lumber that you've added to the stringer. And in our example here, that would be 3/4 of an inch. And the last thing I want to mention will be that you might need to check with your local building department to find out what the minimum width of your set of stairs is, to make sure that you're not making it smaller than that. And most of the time on residential stairs, that will be 36 inches. Here is another problem that some of our newer stair builders are having at our channel, and that's figuring out the starting points and stopping points for the stairway. And even though this rarely happens, you're rarely going to end up with a problem at the top of the stairway. The problem's usually going to be at the bottom of the stairway if you do not calculate the measurements accurately for the individual riser height and tread depth, because you don't know where the stairs are going to stop vertically and horizontally. And here's an example of what I'm talking about, where we have a low riser at the bottom or a taller riser at the bottom, because we didn't know what the finished grade was going to look like. And I'm not about to suggest that you can't solve this problem by regrading the property or by installing new hard surfaces like a concrete sidewalk or by adding more soil to your property. Then you should create some type of a design plan to where you know exactly where the bottom of the stairway will need to stop, the vertical height and the horizontal height, along with the vertical and horizontal height of the upper section of the stairway where it needs to start or stop, to prevent spending unnecessary money on a problem that could have been solved by simply creating some type of a design plan before building your set of stairs. In this video, I am going to try and help one of our viewers who is having a difficult time figuring out if the riser, the last riser at the top of a landing, can be taller or shorter because it's going to the landing, and it cannot be. And even though I did another video on it, I might not have been clear, or should I say crystal clear, but this is actually a flight of stairs. And within a flight of stairs, all of the risers and treads should be the same sizes. However, most building codes allow there to be a maximum variation of 3/8 of an inch. And I'm not going to go into a lot of detail on that. I do have another video on that at our website in the building code section. So the stairways between the floors and the landings or the platforms in this example are a continuous flight of stairs and should be treated that way. However, when we step up from a floor or a platform or a landing up to another floor, landing, or platform, and then go up our set of stairs, it might be a little different. You could actually view this right here as a flight of stairs and separate from this stairway. And if you're having problems with this, you're having problems with a building inspector, feel free to show them this video. However, keep in mind, they are going to have the final say on this, and not me. I'm just simply providing you with an interpretation of the building codes, and their interpretation might be different. Now, if I have a winder step in the landing, then this would be a step and this would be a step. This is not going to be considered a landing unless it meets the specifications for a landing according to your building codes. And in this example here, this would be part of the flight of stairs. And each one of these risers would need to have the same riser height as this flight of stairs here. However, that wouldn't be the case here, where we have a landing stepping up to another landing. So again, this would be considered a flight of stairs. This would be considered a flight of stairs. And then this would be considered a separate flight of stairs. And again, I can't stress this enough. It's going to be up to your local building department to provide you with clarification and their interpretation of their building codes. And hopefully this makes sense. However, if it does not, feel free to leave your questions in the comment area, and I will answer them as soon as possible. Here is a helpful video for anyone who is planning on designing some type of crazy landscaping design in their backyard, where you might be using a variety of different rocks or other building materials that might make your stairway look like it's more of a part of nature than man-made. And I'm here to tell you that out of the 4 of these designs, this is the only one that is going to meet with most of your local building codes. And for those of you who think that your building codes only apply inside the house or maybe in your front yard and not your backyard, well, think again. And I would also like to point out that irregular shaped treads or steps like we have here and here not only might not meet your local building codes, but they're going to make it difficult for people to walk up and down. How do I know? Because I've been walking up and down stairs for a long time, and I've also observed plenty of other people walking up and down a set of stairs. And even a stairway like this isn't always going to be as easy as you might think for someone else to walk up and down. So why do we want to make it more difficult for someone to walk up and down by making wider steps that aren't the same size as the other steps, or by creating some type of an irregular shaped tread, or making matters even worse by not just having an irregular shaped tread, but irregular or different sized risers to make it even more difficult for someone to walk up and down the stairway. And I get it, if you have to do it, you've got to do it, knock yourself out, or at the very least, install a couple of handrails for people to hold on to while they're using your work of art that was built by nature and not man. Here is another quick tip I would like to throw out there for stair builders who are looking for a little stronger connection at the top up here, where the last tread can be used to prevent the stair stringers from separating from the ledger. Now, obviously, this is a little extreme here, so let's go ahead and put that thing back together. And this is normally how it's done. We're going to nail the treads to the stringers. However, if we nail the tread to the ledger, we're going to create a stronger connection point between the stringer and the ledger. We're basically going to use the tread to make that connection stronger by simply attaching it to the ledger. And for those of you who want to even make it a little stronger, then cut the tread a little larger so that we're not going to be nailing at the edge of the ledger. And in this example here, we are using 3/4 inch OSB. And you can see here where the nails are going to be centered in the ledger a little better instead of on the edge. And to do this, all we need to do is have the tread go back a little further and have the riser sit on top of it. Because as someone who has built a lot of stairs in their career, I can tell you that this particular tip right here isn't going to cost you that much more money to create a stronger connection at the top of your stairway. Here is another helpful tip for anyone who is building, repairing, or remodeling a stairway that uses metal brackets to connect the treads to the stringers and would like to relocate the treads either a little farther forward or a little further backwards. And the first thing I want to point out is that the riser height will not be affected at all by moving the treads forward or backwards. And for the most part, by moving the treads forward or backward, you're not going to affect the bottom distance between the front of this tread and the front of this tread. Or in other words, the measurement that is going to be measured by the building inspector. And I do have other videos on that in our stair building code area at the website if you're looking for more information on how to calculate that measurement. However, at the top of the stairway, you're going to have a problem unless the floor, landing, or deck framing is done incorrectly. So in our example here where everything is done correctly, we have an 11-inch measurement between the front of the step and the front of the floor framing. And at the bottom, we have the same thing. We've got 11 inches between the front of the step here, back here, and the front of the step above it. And if you notice the distance right here, we're going to go ahead and change it. We're going to move each one of the steps 2 inches forward. And for those of you who guessed it, at the top, we're going to have a 2-inch gap now between the back of the tread and the floor framing. However, like I said, the riser height wouldn't have changed on this, but the length of the last tread is now 2 inches longer. We have a 13-inch long step at the top. And to fix this, we're going to need to add a filler board to the back of the tread and extend the length of the floor framing by 2 inches. Now, this is one way to fix this. You can add or subtract materials at the top to compensate for whether you're moving the treads forward or backwards. Or we can remove some of the material from the stair stringers. If I take 2 inches off of both sides of the stair stringers, I can shove the entire stairway forward, go back to the original framing, and everything will work out just fine. And if you notice, I drew this line here. This is the same line I drew in our first example and kept it there as a reference point so you can kind of give a better idea of what we're doing. And hopefully this makes sense. However, if it does not, feel free to leave any questions you have about it in the comment area, and I will answer them as soon as possible. Here is another question that I have received quite often, and people want to know, where do the tread sizes come from? And for the most part, they're going to come from your local building code books or local building department officials who can provide you with the minimum sizes for your stair steps. And this is going to be the width and the depth. And again, I said minimum sizes. These minimum sizes will be anywhere from 9 to 10 to 11 inches, depending upon what project you're going to be working on, or whether or not it's going to be for commercial, industrial, public, or private residential home use. And then once you have those measurements, you can go ahead and lay your stairway out on the ground. And that might look something like this when you're done. You might have a landing and then 5 steps. And if the minimum building code requirement is 10 inches, then something like this might work. And keep in mind that even though the depth of each one of the steps is the same, this stairway has 6-inch riser heights going all the way down. This one here has 8 inches. And again, this will be another thing you're going to want to check with your local building department. And I wouldn't be surprised in the future if they change these numbers also. And like I said, you're going to be better off if you don't know a lot about stair building. And that will be to lay out the basic design of the stairway on the ground or on your building foundation floor or even on a sheet of plywood, something that will provide you with a design of the stairway that can be used to pull measurements from if needed to build your stairway. So again, check with your local building department to find out the minimum and maximum sizes for your treads and risers, along with the minimum width of the stairway before building your stairway. Here is another video that one of our viewers requested. And even though I won't be going into all of the details here, I'm not going to be breaking out the pry bars or the sledgehammers and the chainsaws. However, I will be providing you with very basic instructions on how you can take apart most stairways. And that's going to be by simply reversing the assembly process. So let's go ahead and get started by removing each one of the stair steps. And even though I do not suggest that you stand on any part of the stairway that you are removing, I have done it before, but I know what I'm doing. So this process right here, where we're taking apart the stairway from the top, might not work for you. And you might want to take the stairway apart from the bottom so that you won't be standing on it during any time of the demolition. And of course, that would look something like this here. And another thing I would like to point out is that you can remove the center stringers before removing the outside stringers to give you room in here to walk around. And this will definitely be beneficial if the stringers are attached to the wall framing on both sides. And even though I won't be providing you with examples on how to do it, you can always use a saw to cut the stairway components into smaller sections For example, if this stair stringer is attached to a wall, I might want to grab a circular saw and cut it into smaller sections to make it easier to remove from the wall. And don't forget that prying something, if I grab a pry bar and I get it behind the stringer and I'm trying to pry it away from a wall that I don't want to ruin, it's drywalled on the other side or it might have tile on it, then you won't want to use a pry bar because you could damage the wall finish on the other side. And this is where cutting it into smaller sections will benefit you. So remove the inner stringers if that's going to work for you, or the outer stringers first if that's going to work better for you. And if you have a stairway with risers, then you're just simply going to start from the bottom by removing either the tread first or the riser first. So in this example here, we remove the tread first. So tread, then riser, or riser, then tread, whatever's going to work easier for you. And of course, you could always remove all of the treads first and then all of the risers second. And yes, even though it's hard to believe, it wouldn't be a bad idea to create some type of a plan to demolition your stairway. And the last suggestion I would like to make is to be safe, something that people say yet might have a difficult time understanding. So you might consider hiring a professional if you're not comfortable or some of the information in this video doesn't make sense. One of the biggest problems do-it-yourselfers are going to face, and even people who haven't built a lot of stairs, will be to deal with the imperfections in the floor, if there are any, the connection at the top for the stair stringers, and the biggest problem of all is going to be whether or not all of the stair stringers were cut exactly the same. And the best way to figure that out will be to grab a straight edge, usually a level, and place it on top of the stair stringers like we have here. And if there aren't any gaps at all in between the straight edge and the stair stringers, then you have created a nice straight step. And this is ideally what you're shooting for when building a set of stairs. So check everything you possibly can to verify, especially the steps, to build the perfect stairway. So we're going to check in 5 locations: the back, the front, the middle, and the risers can be checked at the top and the bottom. And you can check them also at the middle if you feel like you need to. And again, we're going to be looking for any gaps at all between the stringer and the straight edge. And of course, one of those gaps might look something like this, and you could simply add a filler shim to fix something like this. And you could simply add a shim there to fix something like this. And I think anything around 1/8 of an inch or less, you can probably leave alone. And quite possibly on a riser, even 1/4 of an inch might be okay, depending upon how much of a perfectionist you are. However, 1/4 of an inch for the steps is going to be too much, and you're going to feel it when you use the stairs. And again, I think 1/8 of an inch might be okay for something like this, but I'm going to leave it up to you, because most of the stairs I built, I could check this with a level and within a few minutes fix most of the imperfections, because they were usually going to be in the floor or at the top of the stairway where the stringers connect to the upper floor. And if that was the case, I could usually drive some wedges or shims underneath the stringer that was a little low to make the adjustments that I needed. And if you need a little more information on this, let us know in the comment area, and I'll make another video on most of the problems I dealt with when dealing with situations like this. Here is another question from one of our viewers. They wanted to know how you could raise the risers on a stairway. And I'm guessing that you would be raising the risers if you raised a deck, porch, landing, or floor. And if you did that, then you could add materials to the top of each step. However, you will not be able to add the same thickness to each step. For example, in this situation here, we raised the platform 7 inches and we have 7 risers. However, we will not be able to just simply add 1 inch to each one of the steps to solve this problem, because all that's going to do is make a difference at the top and the bottom. It won't make any difference at all to all of the steps in between. So to solve this problem here, we're going to need to increase the increments of each step by the difference between the existing riser and the new riser height. And to do that, you can simply measure each one of the existing risers. And if they're the same size, great. If not, maybe grab a piece of paper and write down the individual height of each step, or the riser height for each step, and then divide the overall height that you've added to a new floor. For example, we have 7 risers. We've added 7 inches. And if I divide 7 into 7, I'm going to get 1 inch. And that's the amount we're going to add to each step. So 1 inch at the bottom, 2 inches on the next one, 3 inches on the one after that, and then 4 inches, and then of course 5 inches and 6 inches. And in this video, I'm not going to go over how you're going to add the materials because I have plenty of videos on that. Check out our riser variation videos. And don't forget that you can always remove the existing stairway and replace it with another stairway if adding materials like this won't work for your project. In this video, I will provide you with an easy way to calculate and figure out whether or not you can use pre-cut stringers for your project, or whether or not you're going to need to lay them out yourself to make them work for your project. And don't forget that I do have books on laying out stair stringers and building straight stairs at our website. Now, the first thing you're going to need to do will be to measure the length and height of your stairway, because we're going to need these numbers here to calculate the riser height and the tread depth. And the tread depth won't be a problem if the stairs don't need to stop at a specific point. However, the risers will. This is going to be the big problem here. And if you actually want each riser heights to be the same size, there's a very good chance you're not going to be able to use the pre-cut stringers unless you build the deck or floor to match the height for the pre-cut stair stringers. So that covers the risers. The next thing we need to do is think about the steps if they need to stop at a particular point. And this is going to be common in new home construction or remodeling. Another thing we need to consider is local building codes that might require you to have a 10-inch or an 11-inch minimum step and a maximum height for a riser of no more than 7 3/4 inches. However, you would have to check with your local building department in your area to verify this information. And yes, this might seem a little silly, but I've seen it before. When someone who doesn't really know what they're doing needs to make the stairway stop at a particular point using pre-cut stair stringers. And yes, it works both ways, either having a small step at the bottom or a smaller step at the top, or a larger step at the bottom, or a larger step at the top. And the same holds true for the risers. I've seen stairways built with prefabricated stringers that have taller stair steps on the bottom, smaller stair steps on the bottom, and the same up here. Or you could even end up with both a small riser or a tall riser, a small riser and a small riser, or even a combination of something I can't even imagine, because somebody thought that a pre-cut stair stringer was going to work for their project, when in fact it did not. So you can always buy one stair stringer and then put it into a position that you think will work, and then break the level out and make sure that the steps are level, and that all of the tread measurements will be the same, and that all of the riser measurements will be the same. That's one way you can do it. Or if you're starting out with something like this, where you have specific measurements you need to work with, then you can simply start dividing a few numbers until you arrive at the length of your individual treads and the height of your individual risers. So let's go ahead and break out our calculator, and we have 3 foot 7 1/2 inches, and we're going to convert that to inches. So 12 times 3, that's 3 feet, equals 36 inches, plus 7.5 equals 43.5. And we can just divide this number by 7. I'm going to divide it by 7, and that's going to come out with 6.2. Now this is going to tell me that I'm either going to have 6 or 7 risers that will be around 7 inches tall for our stairway. So let's go ahead, clear this, and go back to 43.5. We're going to divide that by 6, and that's going to provide us with 6 7.25-inch risers. And you could always try dividing the next number lower or higher into the overall total rise to see what numbers you get for the individual riser. You might want to use one of those numbers instead. And now that you have the individual riser height, you can go down to your local home improvement center or lumber yard and see if they have a stair stringer that has at least 5 steps and your exact riser height or tread depth that you've calculated. And now for the bad news, if it does not, and it has 7-inch risers, or it's not going to have enough steps, then you're not going to be able to use it. However, you will be able to use it if it has more steps than you need, because you could always cut one of the steps off. And hopefully that makes sense. If not, rewatch the video or go check out some of our other videos on our website. I have plenty of videos on our website showing you how to calculate the individual riser height, tread depths, how to use a framing square to lay out a stair stringer, and like I mentioned earlier, even books that will help you build a variety of different stairways. Here's a quick tip for anyone who is looking for extreme accuracy when building a set of stairs, and that will be to avoid using this part of the tape measure to create an accurate measurement. Instead, add an inch to the measurement. So I was trying to get a 5.5-inch measurement. Move it back an inch, go to 6.5 inches, and then go to the 1-inch mark on the tape measure to make your mark. And you can see here where we have 5.5 inches. However, if I go back here, you can see where the tape measure is a little bit off. It's almost a 1/16 of an inch off if I'm holding the edge of the tape, which is often loose, and loose for a couple of reasons. I'm not going to go into the details on that, the reasons why the edge of the tape measure or the tongue is going to be off a little bit. So again, just simply add an inch. You can add 1/4 of an inch or a 1/2 inch, but it's usually easier for me to add an inch and then go to the 1-inch mark on the tape measure. And I'll even use this method here when checking my treads and risers when setting up my framing square or for other measurements that I need to be within a 32nd of an inch of. Here is another thing that I see stair builders doing that might not be necessary, and that would be adding more stringers or doubling up the stair stringers. And keep in mind that I will not be able to tell you whether or not you need to do this, but I can tell you that I see it plenty of times on the exterior of a building, and if it is, then you could end up with a water trap. And this would be a small gap that would allow water to get trapped in between the lumber. And I'm sure some of you have seen videos where you can put some type of a waterproof membrane on top of the double stringers. But that can also lead to a problem. So my suggestion would be to maybe add 1 or 2 washers in between the stringers and then go ahead and run a bolt through them. If you're looking for a stronger stringer, something like this is going to allow the water to drain out of the area in between the stringers. Or instead of doubling up the stringers, you can just simply lay them out a little different. However, something like this might require a few more nails and could make it difficult to create a straight line between the other stringers so that you don't end up with squeaking stairs. Or you can use larger lumber. You can use lumber that's going to be wider or taller. So instead of using a 2x12, you could always use a 4x12 or a 6x12, or use a 4x14 or a 6x14. or even a single 2x14 instead of a 2x12. And if that isn't working for you, then maybe you can use larger risers or even larger treads. And I'm not about to suggest that you use any of these methods in this video without considering the ultimate option of cutting a huge, massive tree down and carving your own stairway out of a solid piece of lumber. And of course, I'm just joking, because unless you're going to be installing a stairway that needs to be structurally stronger for an industrial or commercial building, for example, then you're probably going to be better off just using the standard construction practices that have been working just fine for decades. Here is another way that you can design layout and figure out the amount of bricks you're going to need for a stairway you're going to build out of bricks. And what I would suggest doing would be to figure out the size of the stairway. Lay out the stair stringer on a sheet of plywood, or lay out the design of the stairway you're planning on building. A stairway that's going to have the exact measurements you need for the treads and the risers. And if you need more information about that, feel free to share it with us in the comment area. And I'll be glad to show you how you can lay out something like this with very little effort. Next, you're going to want to place the bricks in the position that you think they're going to work best. And make sure that you adjust for the brick grout lines, the mortar that will be placed in between the bricks. And you could always do this by cutting some scrap pieces of plywood. For example, if your grout line is going to be 3/8 of an inch, then grab some 3/8 plywood, cut it into scrap pieces to find if you're going to have any problem areas. Like right here, an area where you're going to need to cut the bricks. And basically what you're going to try to do will be to eliminate as much cuts as you possibly can, or change the dimensions of the stairway if possible. And here you can see when we set our next layer or our next rows into position, we're not lining up with the top of our tread. This corner isn't working out here. And in order to make it work, we're going to need to cut this brick here and this brick here. We might not need to cut this brick or install this brick or these bricks here, depending upon whether or not we're going to fill that area with mortar or concrete. Because most brick stairways fill all of the areas they can possibly fill without installing a brick in there to save money, or if it's going to work better for your project. Obviously, you're not going to want to cut any more bricks than you have to. So here's one example of something you can do. Another example that might work would be to change the direction of the bricks. However, you can still see where we're cutting this brick and this brick. And I'm not about to suggest you're going to need to use a full brick here. You could cut this brick in half. You could cut it into thirds. All you need is the front of it. And the same over here. So again, I'm just kind of throwing out some ideas for something that might work on your project. Now with this thing right here, all we need to do to make it work would be to simply make this step a little bit longer. However, if that won't work for your project, you're not going to be able to do it. And of course, here's an example of what the pattern would look like if you're having a difficult time figuring out what the steps and risers would look like on the stairway. Next up, let's go ahead and show you what I'm talking about here. This step is this length here. We're using this, and if we use it, we're going to need to cut a few more bricks. However, that won't be the case if we make the step just a little bit longer, or in your example, maybe a little bit shorter. And this is actually how most stairways are built out of brick. The bricks basically dictate the length or depth of the stair tread, and could be an excellent way for you to figure out how to only cut a few bricks. If we use this example here, we will be able to eliminate this row of bricks here, like we did down here, and only cut the bottom row of bricks, and hopefully no more bricks, but you might need to cut some bricks at the top depending upon how it's going to work out. And if you are going to change the depth of the steps, make sure that you adjust it on your pattern, because you can use this pattern here when building your stairway. Just simply drive some stakes into the ground, firmly secure the sheet of plywood or cut out the stairway design that you're going to use, and then firmly secure that to the ground to make sure that it is plumb, all of your steps are level, and that all of the riser heights are the same. I think this is an excellent way to build a set of stairs for anyone who doesn't know a lot about working with bricks. And of course, the method that most masons are going to use, and that would simply be to cut this row of bricks if the step needs to be a specific depth. And the riser height won't allow you to use full bricks here. And don't forget to allow for the grout joint in the back here, maybe 3/8 of an inch. And this method here will allow you to change the riser heights. You're just simply going to be able to lower the entire step. For example, if I want to lower this 1/2 of an inch, it's just going to lower into this area here. 1 more inch, lower into the area. So the good news is I won't need to cut this row of bricks, but I will need to cut this row of bricks. And I'm not about to suggest you're going to be able to get away from cutting any bricks to build a stairway that will need to meet specific measurements for the risers and the treads. And the last thing I want to point out in the video is don't forget that you can always change the direction of the bricks here, especially if you're interested in reducing the amount of joints. You can see here where we have a lot more joints in here, and this actually looks better in my opinion. So there you have it. If you've never built a stairway out of bricks, something like this could be exactly what you need to lay out the stairway. See if it's going to work and see how many cuts you're going to need to make before you even lay your first brick. In this video, I will provide you with the difference between a step and a landing. And to some of you, this might be obvious, but to others, it isn't. And I get it. You might come across a stairway in your area or on the internet that might have different size steps or landings. However, they might not meet your local building codes. So let's go ahead and talk about what the building codes might suggest in your area, and you would have to check with them to verify the information in this video because different areas have different building codes. And according to most building codes, in a flight of stairs, the depth of the stair tread should be the same measurement. However, it can vary from the smallest measurement to the largest measurement. This would be a maximum variation of 3/8 of an inch. And an example of that would be if the smallest measurement for each one of the stair steps in a flight of stairs is 11 inches. However, I have one that is 11 3/8 of an inch, then this might be acceptable to your building inspector. However, something like this probably won't be. And this is what I seem to run into every once in a while on the internet when looking for creative stair designs that would be approved by most building departments. So again, in a flight of stairs, we can't have more than a 3/8 of an inch variation. Maximum, unless it's a landing. And a landing, according to the International Building Code book, should have the same depth as the width, or at the very least 36 inches for a residential stairway or 44 inches for a stairway with over 50 occupants in the building. And if you do have a situation like this, it should be approved by your local building department. And here's another example that should be approved by most building departments also. And another one that should be okay would be if you had a step between landings. Again, these are not steps. These are landings that meet the minimum building code requirements for a landing. Now let's go ahead and throw a monkey wrench into this one here. This is not a landing. It does not meet the minimum building code requirements for a landing. However, this is something that might be approved by your local building department because in my opinion, this stairway seems safe. Another one that might not be approved, however, you could make the bottom a little bit wider and turn these into circular steps. And I'll give you an idea of that in the next few examples. And of course, another example of something that might be considered a landing by a lot of builders and designers. However, this might not be a landing or a step. It does not have the minimum measurement at this point here. And that would look something like this. According to most building codes, we need a minimum of 6 inches here. And if we put the 6 inches here, and this does not meet the minimum measurements for a landing, then I've got some good news for you, because now this becomes a step. And this would be another stairway that should be approved by your local building department. And believe it or not, this is the reason why I made the video, because one of our viewers was having a difficult time figuring out why this isn't a landing. I would imagine most builders would even refer to this as a landing and not a step. And again, this is not a landing because it does not have the same depth as the width. This right here should be the same length or the same measurement as the width of the stairway, or at the very least meet the minimum depth required, which should be 36 inches for residential stairs, 44 inches for other types of stairs. This is part 2 to a video that I made. I will put the name and a link to that video in the video description box. And I think I figured out a way to have both what I would like to see, which is something like this, and the design you're going to see here in a few seconds. For those of you who believe that this design right here won't work for you because somehow the stringers are going to slide forward even though they're nailed and securely fastened to some base framing plates that are securely fastened to the concrete, or base framing plates that would be securely fastened to a wood framed floor, because either you or the architect think that this is a superior design. I cannot see it. I'm never going to see it, and I'm never going to agree to it, even though I saw this design on almost every set of building plans I worked with. I never used it. I never used it. My dad never used it. And there's no way I'm ever planning on using it because it just doesn't make sense. And the reasons for that can be found in the other video. For those of you who just want a brief explanation, a lot of it has to do with making this notch here and then fastening the stringers to this plate here. And in some cases, I've seen a gap here, and I don't like the gaps. The gaps can cause the stringers to break. And something like this might work fine on a wood-framed floor where you can drive more fasteners through the stringers into the wood-framed floors, or even use framing hardware, where on a concrete slab, you can see where you're only going to be able to attach it to the base framing plate, not to 2 base framing plates like you would have seen in the previous example. So what about this design here? Is this something that might work better for you? You're going to get both of the framing plates, which is what I would like to see, plus a couple of notches that in your mind might prevent the stairs from sliding forward, even though these notches wouldn't be necessary if the stringers are securely fastened to the base framing plate. So something like this would make me happy and make those of you happy who believe that this notch right here is somehow going to work better than the very first example I provided in the video. And if that one seems like too much work, what about this one here? Install the framing plates like I would like to see them installed, and have a notch at the back of the stringer, providing us with another method that might work better than the second example in the video. You're going to be able to use 2 framing plates that you can use to attach the stringers securely to the foundation, and have your notch here to prevent the stairs from sliding forward, to prevent the stringers from sliding forward. If this is actually something you believe will happen, again, even though I've never seen it happen. And if you don't like that idea, what about this one here? Grab a huge piece of lumber and securely anchor it to the foundation. Don't just secure it in the front or in the back. Otherwise, you could end up with the board twisting and forcing one side of the stringer up, and that's probably not going to happen if you have enough base framing anchors to prevent that from happening. So there you have it, and as always, any questions, feel free to leave them in the comment area, and I will answer them as soon as possible. In this video, we will be talking about the 25-inch design rule, and this is simply taking 2 riser heights and 1 tread depth measurement and adding them together to see if you can be between 24 and 26 inches or 1 inch away from 25 inches. So don't bother asking me why they don't call it the between the 24 and 26 rule for designing a comfortable stairway for most people to walk up and down. And for those of you who have watched my channel for a long time, you might have seen the 17.5 inch rule. And that would be when you add the depth of the tread to the height of the riser. And you can see here, if we do that, we have 17.5 inches. This is a comfortable stair step for most people. Here's another comfortable stair step for most people. And if we add these numbers together, we're going to get 25.5 inches. Here's another one that will add up to 24.5 inches and another comfortable stair step for most people. And for those of you wondering who most people might be, that would be the average sized person. And even though I don't have those exact heights, I would be guessing those measurements would be somewhere between 5 and 6 feet. Because this stairway is not going to be comfortable for someone who is 3 foot tall or someone who might be over 7 foot tall. And now to provide you with a few reasons why this formula isn't always going to work. And that would be if we had a situation like this. Because even though this provides us with a fairly comfortable stairway to use, it might not be as comfortable as the ones I just showed you. And definitely not as comfortable as this one here, where we have a small step and a tall riser height. So what should you do with the 25-inch rule for designing stairways? I would simply suggest using it if you have a riser height between 6 and 8 inches, or if you have a tread depth between 10 and 12 inches. And it works within the maximum and minimum building code measurements in your area, which would also fall into the category of most of the stair step measurements you're going to find on a stairway anyway. However, I wouldn't use it for a situation like this or a situation like this. A situation like this, you're going to be taking 2 steps most of the time. And even though that might be comfortable for someone who has a difficult time raising their legs up this tall, maybe an older person, and let's not forget that you can design your stairway for the people who are going to be occupying the property. Just keep in mind that if that property is ever sold, it might not work for the next owner.